My name is Alan Williams, and I've been with Oracle for 17 years now. The first 9 years consulting with the Oracle National Security Group on US government projects. And then when I got tired of traveling, I joined the product management team for database security, where I've been for the past 8 years. I'm very excited to tell you about some new identity capabilities we added to the Oracle database. The Oracle database on a variety of platforms can now integrate with our own Oracle Cloud Infrastructure, OCI Identity Access Management, and with Microsoft Azure AD identity providers. This means that users of these identity services can use their single sign-on credentials to access the Oracle database. We're going to start this with the benefits of integrating with cloud identity services, some of which are the same as with on-premises directory services, but some new ones as well. I'll briefly describe the 3 ways you can use identity services with the Oracle database and which platforms and clients are supported. Then I'll describe the demonstration and show you how to configure the database and Azure AD to allow an Azure AD user to use an Azure AD OAuth 2 token to access the database. We'll start with the benefits of cloud identity integration. Some of these are the same as you'd get with on-premises directory services, such as centralized user management, operationally managing new people joining the organization, employees moving within the organization and shedding, gaining roles, and most importantly, employees leaving the organization. Being able to centrally terminate an employee's access to resources prevents you from leaving local rogue or zombie accounts that can be used by a hacker or the ex-employee to gain access. Centralized account policies so you have a single place to track lockouts and account credential changes. SOD, or separation of duties, so database administrators can focus on managing the database instead of password resets for users on individual databases. And very importantly, single sign-on for the user, so the user doesn't have to manage credentials for every database. But cloud identity integration provides some new benefits, especially in the multi-cloud world where your identity, application, database, and analytic services could exist in different clouds. The first new benefit is that cloud applications have a built-in identity, whether it's an instance principal in Oracle's OCI Cloud or a managed identity in Azure AD. This identity is managed by the cloud and can be used by the application to connect to resources. I know applications can have an identity in directory services, but it's something that needs to be managed by the user and not managed by the infrastructure, i.e. rotating database passwords or other credentials. Azure AD also provides a client credential flow which allows non-cloud apps to have an identity, however, that's not managed. Applications can also request on behalf of tokens for a user or OBO tokens. Since the original user token that the user uses to access the application specifies the application as a target resource, the application needs to request an OBO token to access another resource, let's say the application on behalf of the user, to allow the user to connect through the application all the way to the database. The application connects to the database as a user, not the application. The advantages of this is that the application doesn't have to have a super user account that all users connect through. The user has privileges within the database and can't escalate their own privileges. The database can also theoretically request an OBO token to connect the user to a downstream service like an object store. Applications need to store database usernames and passwords now and have processes to rotate the passwords without downtime. Using tokens associated with the service removes that burden, and the service can connect to the database using native cloud methods. Access tokens not only carry identity information, like your username, but also specify the target resource, like the specific database you're accessing. Depending on the cloud identity service and the resource, the token can also carry additional authorization information, like Azure AD's app roles. Multi-cloud provides additional opportunities. Identity, database, application, and analysis tools can be in different clouds. It's important to be able to work across clouds, especially with the user's identity. And there are different things to consider, and it's based on what application you're using. If you're using Azure AD Identity, but primarily spending your time with OCI services, then it makes more sense to federate Azure AD to OCI IAM and use IAM tokens internally within OCI. But if you're using Azure AD applications and need to use Azure tokens to access the database, then you can integrate the database with Azure AD directly without federation. So what's available today? There are two ways for IAM users to connect with the Oracle database. The first is by using the IAM username and IAM database password, not the OCI console password. The IAM database password is a new parameter, and the database to get the password verifier from IAM instead of storing it in the database for authentication when the user logs in. This is the same as we did with EUS and centrally managed users. This mechanism is great for existing applications and tools that have username database login capability. There's even a rollover capability where a second database password can be added to the IAM profile, so the applications can upgrade the database password on the app servers to the new ones, and then drop the old IAM password without incurring application downtime. The second way is for the client to get the new IAM database token for the user and send that to the database. The database will do the authorization check and map the user to their schema and grant them the appropriate global roles. With both these methods, the Azure AD user can be federated to OCI IAM, but this will only be for the new IAM with identity domains. This federation feature is being currently documented. For Azure AD, the client gets the Azure AD OAuth 2 tokens for the database. This token includes authorization information for the database. This allows users and applications to connect to the database directly using Azure AD OAuth 2 tokens without configuring or managing federation. So availability is typical for cloud releases, limited availability for initial or MVP release, and then adding more platforms. This feature is available with database 19c server only, not on database 21c server. And there are no current plans to add to the database 21c server since this is an innovation release. All these features are available with the autonomous database services. Availability on other platforms will change over time, especially in the table where there's not a yes or no in this slide. Also note that Azure AD integration is available with on-premises Oracle database starting with 19.16, but not IAM. To generalize client support, use the latest database 19c clients, at least 19.16 to get all the token-related features. Database 21c clients have some capabilities, but probably will not be updated with all the capabilities. And then database 23c clients, when they're available, will match the database 19c capabilities. Now I'll describe what I'll be doing in the demonstration. I'll be configuring an Azure AD authorization or auth-z flow with the Oracle Autonomous Databases. This is one of the 4 flows that we support with Azure AD. Users will need to get an Azure AD OAuth 2 token and use that to access the Oracle database. The auth-z flow is a 2-step process for getting the token. First, I'll open a user authentication graphical user interface, which returns an auth-z token. Then using the auth-z token to request the OAuth 2 database access token. Right, and the first step to configure this is to register the database with Azure AD. Using Azure AD app registration, you'll need to add scope or database permission, as well as the app roles for user authorization. And when you do this, take note of some metadata, the tenant ID, the app ID, and the app ID URI. You'll need it when you enable the database to connect with Azure AD. Here's what the Azure AD app registration screen looks like. You'll see it again in the demo. I've mentioned app roles a few times. I'd like to describe them in a bit more detail. App roles are an extension of the OAuth 2 standard used by Microsoft for authorizing principals to a resource. When you configure a resource like the database with app registration, you also add app roles for users. Azure AD users and groups can then be assigned to these resource-specific app roles. An Azure AD user can also be mapped exclusively to a global schema. So this is a bit different than the CMU EUS mechanisms to authorize users. As talked about in the last slide, the next step after registering the database with Azure AD is to assign users and groups to the app roles you added to the database registration. That covers the database registration in Azure AD, and now we move to the Oracle database and configure it for Azure AD integration. There are 2 system parameters that need to be set for Azure AD integration to work. With ADB or Autonomous Shared, it provides a single DBMS Cloud admin command to enable this integration. But you still need to provide the values for both parameters in this single command. With other Oracle databases, you'll need to run 2 alter system commands to set these parameters. You'll need the Azure AD database registration metadata, the tenant ID, the app ID, app ID URI to use here. Once a database is configured to connect with Azure AD, you'll need to create the schema and role mappings for the Azure AD users. The Azure AD user can only be mapped to a single schema, either exclusively with a one-to-one mapping or through an app role. In this demonstration, we'll map a shared schema to an app role, and we'll map a global role to an app role. And that takes care of registering the database server with Azure AD and configuring the database server. Now we also have to register the client. This is important since the client requests the database access token from Azure AD, so the client needs to have permission in Azure AD to get this token for the user. If the application can't request or pass the Azure AD token through the database client API, then the file system must be used, and the database client needs to have some parameters set so it knows when to get a token, when the /login is used, and where the token is. There is no default location for the Azure AD token. These parameters can be set in SQLDet.aura, in the connect string in tnsnames.aura, or used directly on a command line within the connect string. Configuration is done. So what does the user need to do to connect? The user needs to run a process, utility, or script to get an Azure AD token and store it locally. Then the user connects using SQL Plus in this demonstration using /login along with a connect string. Now I'll demonstrate what I just described. Now we'll do the demonstration we just described. First, check into the OCI dashboard, and we'll see in my compartment I've got an ADB shared database instance called Azure DB Demo. That's what we'll be using. This is the only time we'll actually see anything in the dashboard. We're going to be spending most of the time in the Azure AD portal. So go into Azure AD directory. The first thing we want to do is register the database. We'll also register the database client, but first we want to register the database. And this is under app registrations. I'm call new registration. And I'm actually got all this stuff scripted off screen, so I don't have to make any typos. I just need a name in this one. We're going to keep this on a single tenancy. No redirect information is necessary, and register. So that's the first of 4 steps for registering. You got the register. You want to set the scope, app roles, and assigning users. So next is setting a scope, and that you have to set an app ID URI. It's the identity of the database. All right, you want to set that. And they already come out with the app ID in the second half, so we just need to replace the beginning section with the domain name. Make sure it starts with HTTPS because that has to be protected. I'm going to go ahead and save that. And we're going to add a scope. That's a permission. And you'll see this when we set the client. The client has to request permission to access the database. It has to request permission to access the scope. The text for the scope can be anything. Just got to remember it. I happen to use this. Started using that a while back, so that's just what I use now. And it says text if a consent box comes up that you need to enable consent for. So the scope or the permission access to the database is now set up. And I'm going to actually copy this information because I'll need that when I set up the client. Let's go back to the overview. I also need to copy some additional information, that this app client ID for the database. And that's to help when I enable the database. And I need this app ID URI. I also need this tenancy ID for this Azure tenancy. All right, so that's the registration, setting the scope, and now you need to set the app roles. The app roles, what you saw, was a key for the authorization. So I'm going to create 3 different app roles. First is a shared schema for all users to land in. I'm going to call that PDB users, and make that for users. And the description is just pretty simple. Create, but myself as a DBA, I need additional roles to function as DBA. I can't use the same set of roles I get through the shared schema. So I'm going to assign another one that gives me a global role. All right, so that's the And I'm going to show you, we're not going to use this, but an application can also have an app role used to connect to the database. So create 3 app roles. So we register the database, we set the scope or the permission for the database, we added the app roles, and now we need to assign users to it. And that's in the enterprise app version of DBSec Azure demo. This is when you create and register an app, in the tenancy you create the app, it'll actually create an enterprise app with the same name. And if you use this app in another tenancy, it'll create an enterprise app in that particular tenancy. So you'll see that when I open this enterprise app, it's going to look a little different. And it's got the assigned user group. So we'll go in there, and I'm going to assign myself to the shared schema, the PDB users. That's going to let me use that shared schema when I land in the database. I also need to be assigned to the global role as a DBA. So I'm going to also assign myself to the DBA role. There, that's it. And there, shared schema and the DBA role. So that's registering the database on the Azure AD side. Now we want to flip to the database and enable it for Azure integration, and we're going to do that through the PowerShell. We're going to connect to the database, and this is a clean database, so I'm just going to connect as the admin user. Connected, and we're going to see if there's if we're already connected. No, see the identity provider type is none, which means that we are not connected to any identity provider type, whether it's OCI, IAM, or Azure AD. So one of the things I need to do is to specify the application ID as part of this command, and then the app ID URI in the tenancy. So I'm putting this together off screen, and let me copy that here so you can see what I was doing. And so this is AWS, so they have a DBS Cloud Admin single command, enable external authentication, and you pass in Azure AD, and that's going to set this identity provider type. And these parameters will go into the config for telling the database how to connect to Azure AD to get the public key. Make sure these things are correct. There's no validation going on with these strings, so you have to make sure that they're correct when you type them in. All right, let's take a look at the parameter. And now the identity provider type is set to Azure AD, so we're all set. Now we've enabled the database to connect to the Azure. Now we need to set up the shared user. Remember, we're going to have a shared user for all the users. We're going to call it all users, and it's going to be mapped to Azure role equals pdb.users. That's the same app role that I'm assigned to. If you have an HR schema, you can map it to the hr.app Azure role. That's for the application. And for DBAs, they need a global role, so you create a role identified globally as the Azure role equals dba.role. That's the other app role I'm assigned to. Okay, I'm just going to do a quick grant to the schemas, the create session to the 2 schemas, and then the PDB DBA role to the DBA Azure global role. All right, so now I'm done with the database. And now we have to also configure the client or register the client with Azure AD. We've already registered the database. Now we've got to register the database client with Azure AD. And we go back in to Azure AD app registration, just like we did before. We're going to create a new registration. I'll call it DBSec Azure Auth Z flow demo, because we're doing the Auth Z flow, which requires that redirect. We're going to single tenancy. And this is going to be like a SQL, when you have multiple folks using something like SQL Plus to access the database, you don't want them to each have to create their own, or register a separate application for each one of them. So you have a public client. So you don't need to have a secret, you just have to have the client ID, and you can distribute that to all the DBAs. If you're, and because it's auth-z, which requires a redirect, I do need to redirect to my local host, so you have to enter that. And now you register it. Now I need the app ID, because when I request a token later, I need to request a token using this application ID, and this application ID is what has permission to access the database. And now, so in IAM, you have a policy that connects users and resources. In Azure AD, you have permissions that allow a client to access a resource. So now in this client, I need to request an API permission to access the database. So I look for my APIs, DBSec Azure demo. It's a delegated permission for the users. And here's that session that I created, the session scope connect. It's the connect to the database. So I add that permission. So now I have a scope in this, well, I add the scope, but this client now has permission to access the scope. And then grant admin consent, so we don't have to have any pop-ups later. And now the client is allowed to access this database. All right, so now we're all set. This client can access the token for the database. So before we do that, I'm going to go ahead and log out of this, because if I try to get a token using the auth-z flow, it's going to know that I'm already logged in, so it's not going to actually, it's going to bypass that step, and I want you to see that. Let's go into the token. This token script I got from the Microsoft website. There's lots of different ways to get tokens, and our clients don't do that at this time, so you have to get the tokens first on your own. I looked at this particular article, getting Azure AD tokens using the MSAL, because I'm using the auth-z flow, which is a two-step process. It's a lot easier using the MSAL. But this is a great article. It describes how to set this up. A lot of this, which you've already seen, that I just went through, and talks about the REST way of doing it, getting the auth-z code and putting it back into the next REST call. But we just want to use the library, which is can be done through this Python. So this is what I copied to this text file. Now I just need to replace the client ID. Client ID is what I've already got from the database client registration, and you can ignore the oops, sorry, that's the wrong one that appears, the client ID. And now you can ignore this do not modify this variable, because this is the scope of the database, not for Databricks, which this article is written for. There it is. Okay, so we're going to save this, and we should be able to get a token now. I'm going to move to PowerShell, and get out of this one. So you see they got the get token.py that just got changed, and I'm going to go ahead and now try to get the demo. Sorry. There it goes. All right, so it knows I'm not logged in. It asked me to log in. So there it is. And now I'm logged in. That's the auth-z flow in action. It says I can close this window and I go back to PowerShell. You notice that PowerShell it output the access token. That's a JWT token. It's also put it into the file system right there. And this is a JWT token, which means that this is not encrypted, it's just encoded. So we're going to take a look at it. We're going to go to jwt.io and paste it in here, and you can read There's a header that has some of the signature algorithm information, and the payload. It's important to look at the odd claim. Make sure this is the app ID URI that was set. Make sure that it's the right user, and you have the right roles. This is the app roles for this database. This is an access token for this database. So this is very scoped down. You're not going to get every app role you're going to have. It's just for this database. And here's the scope, the sessions scope connect. All right, so the token looks valid. Let's go back to the PowerShell and try to use it. Now we're going to go ahead and now you can put the parameters token auth and token location in SQLnet.aura or in your TNS names, but I just wanted to do a direct on a connect string here so you can see it. You can see token auth equals OAuth, so it knows that when you're using slash and this parameter, it needs to go get a token, and token location is at this location. So let's take a look. And we're connected. Okay, so connecting is usually never that interesting. Let's take a look at some of the syscontext user and data. I'm just going to put it all in and then we'll go scroll through it. So current user is all users. That's that shared schema I was mapped to. Session roles is that global role that I picked up through the other app role I'm assigned to. And here's the DBA Azure is the global role, and the rest of these roles come from the PDB DBA role that I granted to the global role. Now under authenticated identity, I have my Azure AD username. Under enterprise identity, this is the object ID, the OID that came in the, it also came in the token. Authentication method, I'm using token, and this is global. Right? The schema is declared globally. If I use IAM password verify, they would say password global. And because I landed in a shared schema, it said global shared. If I was mapped to a one-to-one exclusive mapping, then it would say global exclusive. So this shows you that I'm using an Azure AD token to access the database in OCI. That completes our demo. Here's what you just saw. We registered the database with Azure AD, added scope and app roles, and then assigned a user to the app roles. We enabled the database, connect with Azure AD, and set up mappings from a global shared schema and a global role to the app roles we just created. The client was registered and then set up with permission of the scope to get a database access token. And then operationally, the user got their token, logged into SQL Plus using /login. The benefits you get with this is that the Azure AD user gets to access the database transparently using their Azure SSO credentials, with app roles providing the authorization. Federation does not have to be configured for this case. Identity integration with cloud identity services provides you the same benefits you could get with on-premises directory service integration, but you can take advantage of cloud-unique capabilities like user identity propagation, managed application identities, and working in the multi-cloud. Thank you.